How's it going, everyone? It's John again. Today's video I'm going to do a demonstration on how to configure Dmvpn, which is Dynamic Multipoint VPN. So if we look at the basic topology, I've got 4 sites here. The top, we've got the corporate headquarters, which is going to act as the hub. It has a private IP address space of 10.0.0.0/24 with a global public IP address of 200.0.0.1/30. It meets the ISP, which has a IP address of 200.0.0.2. Same again in the Manchester office, we've got a private IP address space of 10.1.1.0/24 and a public IP address of 201.0.0.1, meeting the ISP with 201.0.0.2. The same format happens for Glasgow and Dublin, which have got the IP address spaces of 10.2.2.0/24 and 10.3.3.0/24. Now, we've got an issue of peering with the ISP. You can peer with the ISP using BGP. In this case, however, what I'm going to do is just do a default static route. By doing so, each site will be able to ping the edges because, for example, if the Manchester office wants to ping the corporate headquarters, it will ping 200.0.0.1. By doing so, it'll look up its routing table, won't have a route, but it'll pass it to the ISP. The ISP is connected, so it can pass it back. Same for the return traffic. It won't have the 201.0.0.0 network, but it'll pass it to the ISP, which is directly connected, and it'll pass it back to the Manchester office. So effectively, we'll have interconnectivity between the global IP address in here. Now, after that, what I'm going to do is configure EIGRP between all the sites. Here's the thing though, there's not actually going to be an EIGRP neighbor relationship over the physical interfaces through the ISP. The ISP is going to be completely excluded from this peering. Now, if you're new to Dmvpn or just tunneling generally, then you might look at this and think, well, how is this going to actually work? Because an EIGRP neighbor relationship, you'd have to peer it with the ISP, which would peer with the corporate headquarters, and then we could have interconnectivity between them all. That's actually not the case here. What we're going to do is, with each router, its LAN facing interface, that is going to be configured in the EIGRP network statements. And then the actual LAN, which I'm just representing here with one switch, this could be multiple switches, or layer 3 switches rather. I'm just going to put all the networks in that, so effectively all of the LAN will be in the EIGRP statement here, and just the LAN facing section of the router. The actual 200.0.0.0 network will be left out. Same with Manchester 201.0.0.0 network will be left out. Glasgow and Dublin the same. The difference here is how are we going to get these all to have an EIGRP relationship then if they're not actually connecting. We're going to configure an address of 172.16.1.0 as the Dmvpn tunnel. Each one will have a tunnel interface. Corporate headquarters will be 172.16.1.1, Manchester 1.2, Glasgow 1.3, and Dublin 1.4. We're actually going to include those interfaces in the EIGRP neighbor relationship. So we'll actually get an EIGRP neighbor relationship over the ISP through some kind of tunneling overlay. The ISP will be completely oblivious to this connection, but they'll all be able to have full connectivity. Now here's the thing, when connecting offices, we don't want the traffic to just go between Manchester up to corporate headquarters and then down to Dublin if you just want Manchester to connect to Dublin. What we want to do is to have each site be able to build a VPN connection between each site. The problem is that in this case, okay, this is a rather small topology really. There's only 3 branch sites, but if you imagine this is a very large conglomerate with multiple sites, lots and lots of sites, hundreds perhaps. If you can imagine having to manually configure a physical mesh between all offices so that they have a VPN tunnel just so they can communicate securely, that is not very scalable. What Dmvpn does, it basically takes basic information from the hub, and the hub will allow each site to map to one another and create a dynamic VPN tunnel between sites. So effectively, if Manchester wants to connect to Dublin, it will briefly connect to the headquarters, which will transmit information between the two sites, and then the two can build a dynamic VPN tunnel between the two, and then traffic can just flow directly between the two of them rather than having to traverse the headquarters. You imagine if every packet had to go through the headquarters, it would not be very good for the actual headquarters connection. It would get bogged down quickly. So the actual dynamic connection helps with scalability and efficiency. After that, we're going to configure IPsec so that all of the tunnels which are dynamically configured are secure, so they can actually transmit the data with full encryption. So with that little preamble, let's go and configure the basic configurations now. So what I will say is I've not configured any EIGRP on this, nor have I configured any of the default routes. The basic IP addressing is configured apart from the Dmvpn tunnel addressing. So let's first start up here at the headquarters. What I'm going to do is EIGRP on this router and just do the private IP addressing. That's going to be included. The 10.0.0.0 network will be included, and I will not include the public IP address. Same here. 10.1.1.1.0 will be included, but not the 201.0.0.1. Once we configure the tunnel interface, they will then be included in the EIGRP network statements. In the case of all the switches which are acting as the entire LAN, this could be multiple switches. I'm just abstracting that and showing it as one single switch. The network statement on that will just be to include all the networks. So network 0.0.0.0, so that if we add loopbacks in that, they will all be included. So with that, let's go and do it then. So let's start up at the headquarters then. So we're on the headquarters edge router, and the first thing what I'm going to do is configure that default route. And the default route is going to the interface which connects with the ISP on the headquarters is gigabit 00. So we're going to say push all default traffic out of the gigabit 00 interface. Now, let's do router EIGRP autonomous system number 10, no auto summary, and the network which we want to include is just simply the 10.0.0.0 network just now. Okay, now that's that configured. Let's go and move up to the core switch up here. Okay, so we'll do enable. Oh, no, just let that finish. I don't get that with the viral thing. When you actually go to do the Control-Shift-6 to abort that, it still doesn't abort immediately. It's kind of strange. So, router, EIGRP 10, no auto summary. In this case, we're not going to be so specific. We're just going to include all networks. So that's us get a basic EIGRP relationship here between these sites. Now, we're going to do the same thing down at the Manchester office. So let's go to branch 1, which is going to be Manchester. And okay, now this interface here, this is actually gigabit 01, so the default route will be slightly different. We'll do IP route quad zeros, and we're going to push that out gigabit 01 this time, not gigabit 00. And we're going to do router EIGRP 10. We'll no auto summarize it, and we'll put the network of 10.1.1.0 this time, and 255. Now if we go to the Manchester switch down here, same again, all the networks to include in that one. And we'll do enable conf t and router EIGRP 10, no auto summary, and put in all the networks. And that's that up. Now we go down to the actual branch of the Glasgow. This one there. So we're going to put the LAN facing interface on this one. So branch 2, Glasgow. And the default route for this one is out gigabit 02 this time. So this interface here, this one, this is gigabit 02. So gig02, and now we do router EIGRP10, no auto summarize it, and the address we're doing is 10.2220. And we go to the Glasgow switch down here, same again, just include all the networks in that one. So we'll do enable, configure terminal, router EIGRP10, no auto summary, and we'll include all the networks. The adjacency should pop up. There we go. And lastly, same again on branch office 3. The default interface will be gigabit 03 in this one. So we'll do IP route and gig03, and we'll do router EIGRP10, we'll no auto summarize it, and the network is 10.330. Let's go to the Dublin switch and include all the networks. Enable, configure terminal, router EIGRP10, no auto summary, and include. Okay, so that's us got a neighbor relationship between each site and its LAN facing switch. Here, but there's no EIGRP between them all yet. So what I'm going to do is first just check that we've got basic connectivity between the branches. So let's try to ping the corporate headquarters using that default route, so 200.0.0.1. We should lose a few packets, but it should actually ping. There we go. Try that again. That's us good. Same again here. Let's try to ping 200 using the default routes. Again, should lose 2 packets. There we go. And lastly, let's try that with the Manchester and make sure everything's working fine. There we go. So we can now, every site can ping the remote office, no bother. Now, so what we need to do here is we're going to go on to this hub here, this router rather, and it's going to act as the hub router for the Dmvpn. So the configurations on this tunnel interface is going to be slightly different than what it is for the Manchester, Glasgow and Dublin offices. So what I'm going to do is to interface tunnel 0 and configure the first IP address in this address space, which is 172.16.1.1. I'm going to duck back out, include that in my EIGRP network statement, and then go back into the tunnel interface and start configuring the Dmvpn. So let's go and do that just now then. So we're going to go in the hub, and we are going to do interface tunnel 0. Do you know what? Let's change that a little bit. Okay, so we'll do IP address, and we'll do 172.16.1.1. Okay, so that's us get that. We're going to exit out. We're going to router EIGRP10, and we're going to include that network statement. Okay. Now go back into the tunnel. Now here is the thing. With Dmvpn, the main thing you're looking for is IPnHRP, which is Next Hop Resolution Protocol. That's pretty much going to be your main configurations for Dmvpn. Now the first thing we need to configure is the network ID. See this one here? This can be any number you want, but it does need to match between all sites, because that's going to identify each tunnel as a member of the same group. So we're going to choose the number of, let's go with 5. So we'll do network ID 5. Now this has to match on all sites. So you've got to remember, we've got to use 5 for every single one. Now we'll do IPnHRP, and we're going to say, because this is the hub, the multicast, so the multicast, map first, map multicast, and this is the hub, and we're going to basically inform it to have dynamic mapping, so every site's going to use this one to dynamically find the mapping for the other sites. So IPNHRP map multicast dynamic. Okay. Now the next thing we need to do is, let's just check that. IPNHRP. I've done the network, haven't I? I've done the map. Yep, that's fine. Okay. Now let's go into our tunnel. Okay, back in the tunnel. Now what we need to do is specify the tunnel source. The tunnel source is going to be, let me just show you, this exit interface here. That's the source of the tunnel. In that case, it's going to be gigabit 00. In this case, it's going to be gigabit 01, gigabit 02, gigabit 03. So let's do that just now. And we'll do tunnel source gigabit 00. Now that's just configured the source. If you're used to doing GRE tunnels, you would configure the destination. We're not going to do that. Just the destination is going to be tunnel mode multipoint, because it's a multi-point connection. Now, what we need to do is go over to the Manchester office and do the same thing, but with slightly different configurations. So let's go to Manchester now, which is branch 1, and we'll give that the second address, which is going to be 172.16.1.2. And we'll go out, we'll add that to our EIGRP network statement. And go back into the tunnel. Now we need to do IP NHRP. The network ID we did was 5. So that's going to be that. IP NHRP. Nope. Type that right. And right, okay. So now we're going to do multicast, but it's not dynamic. We're going to have to do, if you look at this is when you're configuring Dmvpns. If you use the context sensitive help, the question mark, the actual description here is, see when you see NBMA, think of that as the public IP address. If you see IP NBMA, public IP address, if it just says IP address, think of the tunnel address. So we want to map it to the actual hub, which is up here. Okay, we're going to get that information from here, but it's the NBMA address, so think of that as the global address. So we're going 200.0.0.1 here. So let's pop that in. 200.0.0.1. Okay, and IP NHRP, and we're also going to map the IP address of the hub. Now it just says IP address here, so think of the tunnel interface. So the tunnel interface of the hub was 172.16.1.1, and map it to its global address, which is 200.0.0.1. The next thing we need to do is do NHRP next hop server. Again, the question mark, it will show you that it's just IP address, not the NMBA one. So we do with the 172.16.1.1. That's going to be the tunnel address, and that's that there. And now we do tunnel source, and like I said, the tunnel source for this one is gigabit 01. So let's do that now. And then tunnel mode, once I put multipoint in, we should have this pop up, and an EIGRP neighbor adjacency should also pop up. There we go. So let's do the same thing over on the Glasgow edge. We should go in and do interface tunnel 0. We'll do IP address 172.16.1.3 this time, and we'll exit out. We'll go into the router EIGRP 10 and add that to the network statement. Back into the tunnel, and we need to start configuring our IP NHRP network ID, which is going to be 5, remember. we do IPNHRP, and we need to map the multicast. And like I say, if you forget if it's public or private, in this case it's public, but if you forget, question mark, and it's the NBMA address, so you know you're using the hub's public address. You also need to tell it, next hop, map, and we're going to map the, like I say, private to the public. So you see that there, it just says IP address. So if it's IP address, just think the tunnel address, which is the private IP address, and map that to the NBMA address, which is the public one. Next thing we do is the IPNHRP next hop server, and again it's going to be the private address, and we know that because it just says IP address, not NBMA. And now we just do tunnel source. In the case of the Glasgow one, it is going to be gigabit 02, this one here. So the tunnel source is going to be gig 02. And the tunnel mode, again, is going to be GRE multipoint, and this should bring up an EIGRP neighbor relationship. There we go. So let's slide over to the Dublin edge. Same again, interface tunnel 0. We're going to use 16.1.4 this time. And we'll go into EIGRP, include it in our network statement. And back into the tunnel. I'm going to do IPNHRP network ID is 5, IPNHRP map multicast to the 201 IPNHRP. I'm going to map the private to the public, and then do, forgetting the next hop server command. Next hop server is going to be the private. And tunnel source in this case is going to be gigabit 03. And tunnel mode is GRE multipoint. We should have an EIGRP relationship pop up. Okay, now, so here's the interesting thing though, right? What I'm going to do is configure a loopback address on this switch here, and all of these sites should now be able to see this. So I'll configure a loopback of all the ones. So let's go up to the core switch, and we'll do int loop 1 IP address, and that's that. Okay, so now let's go down to, say, the Dublin switch. Does it see it? No, rather show IP route. And there it's there, all the ones. Can it ping it? Yes, it can. Same again, if we go to the Glasgow switch. All the ones, can it ping it? Yep. And lastly, with the Manchester switch. That should be show IP route. It can see all the ones, and can we ping? Yep. Okay, so I've advertised a route from the hub, and all the sites can see it. Now here's an interesting thing though, right? What if we advertise a network on the Dublin switch? Let's give this all the 4s on Dublin switch. Let's see if the same thing happens or something different happens. Maybe you can see where I'm going with this already, but if not, just int loop 4, and we'll put all the 4s on that. Okay, now if we go to the actual hub, the core switch, will we see all the 4s? I think we probably will. Let's have a look. Okay, no problem there. Let's ping it, make sure it's all right. Okay, so where's the problem? The problem is if we go to one of the other spokes. So we're advertising this here, all the 4s. What about the Manchester switch? Can that see it? let's do a show IP route. Doesn't see the 4s. What about on the Glasgow switch? Will that see all the 4s? Show IP route. Right, okay, so what's the problem here? We've advertised a route out here, and it's got to here, but the spoke has not advertised it back out there, nor has it advertised back out there. Now we're using a distance vector protocol here, so you might be thinking it's split horizon. So effectively what it is the loop prevention in distance vector is you don't advertise a route back out the interface in which it came in. So 4.4.4.4s came through here, went into the hub, but the hub's not advertising it back out to here or here because it's trying to prevent the loop. So it thinks. So what we need to do is go on to the actual tunnel interface and disable split horizon for EIGRP autonomous system number 10. So let's go in the hub and do that now then. So let's go to the hub and we'll do interface tunnel 0 and we'll do no IP split horizon EIGRP 10 and it should resync. Okay, so now let's go to the Manchester switch now and we'll try that command again. And now it's advertising the 4s. You see that now? Didn't have it before. Now we've got the 4s. Try with the Glasgow. Oh, if I don't mash the keypad. And now we have all the 4s. Okay, so that's interesting. We can now dynamically pass routes between all of the sites. So let's try to ping from Manchester to Dublin. So we'll ping from the Manchester switch right in here, right to the loop back here of all the 4s. So we'll go to Manchester switch and let's ping that. Okay, let's trace it. Let's see the path it's going though. Okay, so it's going to 10.1.1.1, which is there. That's right. Now, where does it go next? So this is the important part. Right, it's went to the hub. 1.1, which is the hub interface. And now it's going to the tunnel interface of the Dublin. And that's it finished there. Okay, so look, it's went here, up to here, 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 and here. That's not what we want. What we want to do is to prevent a bottleneck happening between the corporate headquarters. We just want to use that as the base. Just want to use the hub as the hub for the basic information through which to dynamically establish the VPN connection dynamically. But we actually want to pass traffic directly between the offices. We don't want to go up through here and through here for every single packet. We want to use that to build the tunnel and then just be able to communicate between the two of them. So what we need to do is go into the tunnel and type in the command no IP next hop self EIGRP 10 on the tunnel interface up here. That's going to instruct it to build the tunnels to allow traffic to traverse directly rather than having to go through the tunnel of the main site. So let's go up here and we'll do interface tunnel 0 and we'll do no IP next hop self EIGRP 10. We get that resync on the go. And if we go back to the Manchester and we ping all the 4s again. Right, and now we trace again. Let's have a look at the path this time. That was it before. It went 10.1.1.1. That should still be the same. We should miss out the 172.16.1.1 and go straight to the 1.4. So we'd only have 3 hops rather than 4 this time. Okay, that's right, first one. This is the all-important one. We'll go to 1.4. And there it's going straight to 1.4. And then 10.332. And that's it. So the path this time, it's missed out this hop. It's only taken 1, 2, 3 hops rather than 4. So now traffic is dynamically building the tunnel between the sites, but the traffic, once established, is now going directly between the two of them, which is great. The last thing what we need to do is to secure this traffic. So what I've done is I've built this little IPsec profile, and now this is just your basic IPsec configuration. Really, if you look at it, it's just your basic 3 stages. The only difference is here is the address I've mapped to all the zeros, which is going to include all addresses. So effectively, crypto ISACANT policy 1, encryption AES, we're going to use the pre-share key, not a certificate. Group 14, the password is going to be Cisco and the address is going to match everything. Transport set John, mode is transport. We're going to create a profile called IPvZero and then put the transform set John, which is this bit here, into that. And then on the tunnel, we're going to apply the IPvSec profile, which we created here. So all we'll do is, to save time, we'll just copy you, and let's go to the hub and paste this in. Okay. And we'll go to branch 1. And branch 2. And branch 3. And if we ping from the Manchester switch, just ping that again, and we go to the branch. Oh, that's what we want, idle, and IPsec. And we've got our packets encrypted there. So now we have our packets being transmitted via AES encryption between sites, dynamically establishing tunnels, and not having to traverse a path through the hub for every single packet. So we're going to have a much more efficient traffic path. Okie doke. So that's the end of the video. The next one I'll do probably will not be in Dmvpn, but in future I want to do the same thing, but go through it with OSPF, because this is a distance vector one, which you had the split horizon problem, and OSPF has got some little wrinkles you need to work out as well. So that's the end of the video, and thanks very much, and I'll see you guys soon. Bye.